In the previous lecture, we talked about the first law of thermodynamics and learned how to calculate the work, the heat, the change in energy, and the change in enthalpy for systems undergoing isothermal compression or expansion, isobaric or isochoric heating or cooling. We also learned to do similar calculations for phase transformations and for chemical reactions under isothermal and isobaric conditions. Our approach in Chapter 1 on the first law was to consider the energy transactions associated with processes, that is, with the evolution of a system from one state to another state. Until now, we did not really ask whether the process occurred by itself, that is, spontaneously, or whether the system was in an equilibrium state. Over the next 4 lectures, we are going to shift our emphasis onto the topic of spontaneity, reversibility, and equilibrium. We will learn to identify the direction in which a process between two states of a system is spontaneous, and the conditions under which a system can exist at equilibrium in two different states. In today's lecture, we will learn about the word spontaneity by looking at specific examples you are all familiar with. We will then define the word spontaneity by invoking whether or not work must be done on the system for the process to take place. We will then examine whether spontaneity can be explained by a specific change in the energy or the enthalpy of the system, or by a change in the level of order or disorder in the system. We will define a general criterion for the direction of spontaneous change and proceed to quantify this criterion by defining the concept of entropy and stating the second law of thermodynamics. We then describe the various mathematical steps involved when actually using the second law of thermodynamics to determine the direction of spontaneous change. We provide a general definition for the entropy change of the system and for that of the surroundings. Finally, we go through the derivation of entropy changes for reversible isothermal compression or expansion and for isobaric or isochoric heating or cooling of pure substances.